Hello, welcome to the video Rational Root Theorem. Our essential question is, how do we use the rational root theorem to determine all possible rational roots or zeros of a function? So let's go ahead and start off with the rational root theorem. Rational root theorem says that if the polynomial f of x is equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1, and you continue on until you get to a sub 2 x to the second plus a sub 1 x plus a sub 0, which is your constant. If this polynomial has integer coefficients, that would be numbers like positive negative 1, positive negative 2, etc. Every rational zero of f has the form p divided by q. And this is called a rational root, where p and q have no common factors other than 1, and p is a factor of the constant term a sub 0, so this term at the end, and q is a factor of the lead coefficient a sub n. Now again, the key to this is that your polynomial is in descending order, just like we always set it up. Your lead coefficient q is the coefficient of your first term with the biggest exponent, and p is a factor of the constant term a sub 0, which is the term at the end. Okay. Now one thing to note, remember that a rational number is any number that can be rewritten as a fraction. Alright, let's go ahead and pause, copy down your rational root theorem, and we will continue on with our notes. Example 1. Determine all the possible rational roots of f of x equals x to the fourth minus x cubed plus x squared minus 3x minus 6. Notice that this is in descending order, so we are ready to determine all of our possible rational roots. The first thing we're going to do is figure out what p is. P is going to be all the possible factors of 6 over here, negative 6. So if you think about all the numbers that multiply to give you a negative 6, it could be a positive or negative 1. It could be positive or negative 2, positive or negative 3, and positive or negative 6. These are the numbers that will divide cleanly into negative 6. Now for our q numbers, we go to the lead coefficient, and you'll notice that the lead coefficient of this particular term is a 1. Well, the only number that divides into 1 is positive or negative 1. Now that I have all of my possible p's and all of my possible q's, now I'm going to set up my possible rational roots. So I'm going to take p and divide by q. So we have positive negative 1 over positive negative 1, positive negative 2 over positive negative 1, positive negative 3 over positive negative 1, and positive negative 6 over positive negative 1. These are all my possible combinations. If I had another q number, then I would take all those 4 numbers and put it over that second set of q numbers. Now that I've set these up, now I'm just going to simplify it. If it's positive or negative and you're dividing by a positive or negative, they basically cancel each other out, so we end up with positive or negative 1, positive or negative 2, positive or negative 3, positive or negative 6. So we have a total of 8 possible rational roots that we could try that would possibly work in this equation. Go ahead and pause, finish copying this example, and we'll move on to example 2. Example 2, determine all possible rational roots of f of x equals 3x to the fifth minus 2x squared plus 9x minus 18. So first thing I check, make sure it's in descending order, which it is. Now I'm going to list out my possible factors for my p term. 18 divides by 1, so we have positive negative 1. It also divides by 2, positive negative 2. 3 will go in there, so we have positive negative 3. 4 does not divide into 18, 5 does not divide into 18, 6 does, we have positive negative 6, 7 does not, 8 does not, 9 divides in there, And if you continued on, the last number that will divide in there is positive or negative 18. So I have my p's listed. Now we're going to list our q's. This time, my lead coefficient is a 3. It's not a 1. So the numbers that will divide into 3 are positive, negative 1, and positive, negative 3. And now we're ready to list out our rational root possibilities. So p divided by q. So I'm going to take each one of these p's and divide it by 1, and then I'm going to take each one of the p's and divide it by 3. So we got positive, negative 1 over positive, negative 1, and again 2 divided by the 1, positive, negative 3 divided by the positive, negative 1, etc. So I'm just taking each one of these p's and dividing it by the first q, and then I'm going to take each one of the p's and divide it by the second q. So you see you have quite an extensive list. So I have 6 of them, actually 12 of them so far, because you got positive or negative. And then we're going to take all of these and we're going to divide it by the positive or negative 3 as well. So positive, negative 1 over positive, negative 3. And once you have set all of these up, then you're going to go back and reduce and get rid of repeats. So positive, negative 3 divided by positive, negative 3. That's positive, negative 6 divided by the positive, negative 3. Positive, negative 9 divided by positive, negative 3. And then the positive, negative 18 divided by the positive, negative 3. So now that I have them all listed out, now we're just going to go through and reduce. And when it's a repeat, we're just going to cross it out. So 1 divided by 1, we get the 1. 2 divided by 1, we get positive, negative 2. 3 divided by 1, positive, negative 3. 6 divided by 1, positive, negative 6. 9 divided by 1, positive, negative 9. And then we get our positive, negative 18. 1 divided by 3, we haven't seen that one yet, so that's a new and a unique one. So we're going to go ahead and list it. It's 1/3, positive or negative. And then we have positive or negative 2/3. Positive, negative 3 divided by positive, negative 3 becomes 1, and we already have that one listed, so I don't need to repeat this one. Positive, negative 6 divided by positive, negative 3 is positive, negative 2, which we also already have, so we don't need to list that one. Positive, negative 9 divided by positive, negative 3 is positive, negative 3, which we already have, so we can cross that one out. And then 18 divided by 3 gives us the positive, negative 6, which we also already have. So we have a total of 16 possible rational roots that we could try if we were solving this problem. So these are my p over q's. You could go back and list them in order, but just as long as you've got all of them listed, you're in good shape. Go ahead and pause, finish copying that one, and we'll continue on to the last example. Okay, example number 3, it says determine all possible rational zeros. Then we're going to determine the actual rational zeros. So we're going to solve it after we figure out all the possible ones. So let's go ahead and do that. First, we got to figure out our p's and q's. Notice it's in descending order, so we're in good shape there. So let's list out our p's. P's are our possible factors of 2. So we have positive, negative 1, and we have positive, negative 2. Those are the 4 numbers that will divide into 2. And now when we list our q's, well, our lead coefficient is a 1, so we only have positive, negative 1 for our q's. So our p divided by q's, all of our possible rational roots, is going to be positive, negative 1 over 1, positive, negative 2 over 1. So I don't have a whole lot to choose from on this particular problem. So when we simplify that down, the only numbers that we can possibly try that will work in this problem are positive, negative 1 and positive, negative 2. So now that I know all of my possible rational zeros or roots, now I'm going to figure out which ones actually work. So I'm going to take my equation, x cubed plus 4x squared plus 5x plus 2, and I am going to break it down using synthetic division, and I'm going to see which ones of these work. So the first one I'm going to try, you can try any one of them. You can try positive 1, negative 1, positive 2, negative 2. I'm going to try, since I see that 2 on the end, I figure a 2 probably is going to work in there. So I'm going to try positive 2. Okay? You try the one that you think will work first. And if you only have a few of them, then it just makes it so much simpler because you get it down to which ones work and which ones don't. So doing my synthetic division, bring down the 1. 1 times 2 is 2, 4 plus 2 is 6, 6 times 2 is 12, 12 plus 5 is 17. At this point, I can see it's not going to work. You can finish it all the way out, but I can clearly see that this is not going to work because I don't get 0. And remember, my job is to get 0 in order for it to be a factor. So positive 2 didn't work, which means x minus 2, remember, if I have a positive 2, that means that my factor is x minus 2. That means that x minus 2 is not a factor. Okay, and this is all based on the factor theorem, which says if you get a 0 as your remainder, then whatever you divided by is a factor. Well, we didn't get 0, we got 36, so x minus 2 is not a factor. Alright, that does not deter me. I'm going to go ahead and try negative 2 now. So if I try negative 2, using the same 4 coefficients, bring down the 1, 1 times negative 2 is negative 2, 4 plus negative 2 is 2, 2 times negative 2 is negative 4, 5 plus negative 4 is 1, 1 times negative 2 is negative 2, 2 times negative 2 is, or 2 plus negative 2 is 0. Success! This means that x plus 2 is a factor. So far, I know that x plus 2 goes in there. So what do I have left? Well, what I have left is x squared plus 2x plus 1. So if I know how to factor this, I can finish solving it. But if I don't know how to factor it, I can use quadratic formula, or I can use completing the square to finish solving it. I know how to factor, so I'm going to go ahead and factor this. But otherwise, use your quadratic formula or completing the square to complete the process. So x times x is x squared, 1 times 1 is 1, and when I put 2 plus signs in here, 1x plus 1x gives me 2x. So I factored it successfully. So now if I want to finish solving it and finding the zeros, we already know that negative 2 is a 0. My last two zeros are found by taking these factors and setting them equal to 0 and solve. And you'll notice they're exactly the same, so I should get the same answer twice. So negative 1 is going to work, and negative 1. Remember, this is called a double root, or a multiplicity. So negative 2 is a 0. We also have that negative 1, and negative 1 are zeros as well. So we have successfully found all the possible rational zeros, and we have found the rational zeros. And these are your rational zeros for the function x cubed plus 4x squared plus 5x plus 2. And that's your final solution. Go ahead and finish copying this, and then I hope you have a wonderful day.